This is a production of Cornell University.
Today, we're going to be going out to the compost facilities. This week, we're going to be going out to the compost facility. And I know my segue. Okay, so from a management perspective, what is one of the things that we manage? I mean, if you think from a very dramatic sense, if we're talking about organic matter, from a management perspective, one of the most dramatic management tools that we use is composting, right? It's hot and heavy right now. Everybody's into it, right? Okay, but even if we're not actively composting, we are composting all the time. All of our material that goes to landfills and stuff like that, it's composting. It may be composting really slowly because the system goes anaerobic, but it's composting. Okay, and because this is one of the most dramatic, and you guys are going to be visiting a compost facility this week, I thought maybe we should actually talk about a composting operation. Okay, and what in fact should we expect to see? Okay, when we're talking about managing this organic matter. Okay, so one of the purposes, I don't know if you guys remember this slide. Oh, I don't want to do this anymore. I drive you guys crazy when I swap slides. Okay, but one of the major purposes for organic matter management is to dispose of the organic matter. Okay, one of the new tools, though it's not really new, it's just been used more now, is composting. Okay, there's huge benefits, and we'll talk about those in a second. But let's actually talk about what composting is. Okay, so composting is basically in essence, when it's done right, it's basically a three-phased system, okay? Where you're looking at a period of time, an amount of temperature, and an amount of material that's degrading, okay? We're getting rid of material and we're converting it into something else, okay? Now, there are basically three stages of composting, professional composting. The first stage is what we call a mesophilic stage, okay? It's a fairly warm but not hot system, okay? We're basically digesting the simple stuff, the stuff that's very quickly digested, and this is a really good example about where the structure of the material, the recalcitrance of the material actually makes sense, because in this scenario, everything's been packed together and space no longer really becomes an issue, okay? We manage the space. Okay, that location now becomes managed. Okay, initial stages we call a mesophilic stage. Okay, it's really right in here, and if this is the material, this dotted line right here, this is the amount of material. Okay, this line right here is temperature, and this is humic acid. This is the material that comes out. This is the leachate that comes out of the system. Okay, so waste, temperature. Waste, humic material, waste, or the response to the organic material. Now the reality is it would be really nice if we had a CO2 number in here as well, so you could have an idea about what the biological activity is, but that biological activity is going to be something like this, much like you have seen in the past on those other graphs. Okay, so mesophilic stage right here, simple sugars, simple materials, easily digested materials are the first to go, okay? And if that happens, what's going to happen with my population? The population that are doing the decomposition. If I put a food stock down, what's going to happen to my population? It's going to start growing, right? And so I have a huge burst of growth. Now, when I start having that huge burst of growth, yes, I'm going to evolve a lot of CO2, but these are active organisms. What's going to start happening to the temperature? It's going to start getting hot, okay? And in fact, the heat is going to get so high that it potentially will kill off these organisms. Now, interestingly enough, there's a whole host of organisms that are out there that actually do better in higher temperatures, okay? When this heat profile gets up into the 50s to 75 degrees Celsius range, we move into what we call the thermophilic stage. Okay? We're starting to see some of the less palatable materials being decomposed. We start seeing the celluloses being decomposed. Okay? Gets up fairly high. Now, sooner or later, this material, we're going to start running out of this material. Okay? And on top of it, we're killing off a lot of the mesophilic stuff that were in the very first stage, stage 1. As a result, my CO2 profile is going to start coming down, which means my population is becoming less active. As that population becomes less active, the temperature starts to drop. Okay? Once that temperature drops down enough, these thermophilic organisms, their population is going to be depressed. They're going to start losing, and the mesophilic organisms are going to start coming back. This is what we call this is the curing process. There's still a lot of organic material for them to decompose, but all the easy stuff and much of the cellulose has basically been decomposed off. Okay? And we're looking at these secondary materials. Okay? We have lots of recolonization. We basically sterilized by going really high. We basically sterilized, not truly sterilized, but we basically killed off a lot of these mesophilic organisms. So those organisms actually need to recolonize. Okay? Now, we have a huge amount of recolonization, and in the same period of time, look at these humic acids. Do you guys remember we talking about the humic acids tend to act like hormones, plant hormones? Okay, and so as a result, we see an increase in stimulating hormones for plants, and we also see an increase in hormones that are detrimental to plant pathogens, as well as a decrease in the compost temperature. Okay, so that temperature is dropping right in here, and that's where you see this huge increase right in here of these humic acids. So in essence, those are the 3 stages of a thermophilic compost operation. This is the compost operation that we're going to be seeing this week. Okay, so first stage, simple materials get decomposed. Population booms. Population booms, the temperature starts to increase. Temperature starts to increase, we start killing off the mesophilic organisms, and we move into thermophilic stage where we have the thermophilic organisms taking over. They start decomposing, but the decomposition processes are getting slower, which means the temperatures start to drop. When the temperatures drop enough, the mesophilic stage 2 starts again, where the material gets recolonized by all the organisms that got killed off up here. Okay? Both beneficial and pathogens. And we have all these secondary products appearing. Okay? Does that make sense to everybody? That in a nutshell is that in a nutshell is what we're trying to do with decomposition. Now, 2 important points. First point is take a look at the amount of material. You started with this, you end with this. That's a big drop. Okay, now timeline, we're looking at 140 days here. Generally, that's probably about right. My system's probably a lot longer than that because I don't really get into this mesophilic stage or the thermophilic stage. But composting, if you do it right, you're looking at a couple months of question.
Well, I'm still stuck on the lignin thing. Where is that now in this process?
See. That's a good point. So the question was, I'm still stuck on this lignin thing. Where is that in here? Okay. Now, because of this is a composting operation, we have basically modified this issue of location. Okay. In a natural system, where the material goes and how it moves into the system is based on natural processes. Okay. Worms bring something down. Some sort of landslide buries something. Okay. Material sloughed off a root in one location, not in another. In this scenario, we are mixing this material. We are bringing all of the stuff that needs to be decomposed right together. We're putting the population, we're creating a perfect environment. We're creating an environment where we optimize decomposition. Which means that location is less important because we're modifying location and CN ratios and structure becomes more important. Does that make sense to everybody? What? Throughout this whole thing. Oh, where's the lignin decomposing? The lignin is decomposing throughout this thing, throughout it. And the celluloses are decomposing throughout it. And the sugars are decomposing out. But I'm just saying that these are the ones that tend to get hit first because they're the least resistant to decay. You get them into these thermophilics, and we're looking at the cellulosic materials that are being decomposed. But the reality is all of these things are being decomposed at the same time. It's just that up here, we tend to be predominantly in the easier stuff. Down here, because most of the easier stuff has been pulled out, moving into the harder stuff. Go.
So humic acid in a compost system, would that emerge from the simple sugars decomposing with cellulose?
No, so the question is, where is these humic and fulvic acids coming from? What's their primary source? In reality, they're probably more coming from these more recalcitrant materials, okay? Because the simple sugars, the byproduct there isn't one. The humic and fulvic acids are byproducts, okay? So I've got to have something left to turn into that's going to be turned into these humic and fulvic acids by the organisms. Simple sugars, they're gone. Yeah. Question?
How do they know that it's reached the end? Like, are they monitoring the humic?
So how do they know it's reached this point down here?
Yeah, because the temperature's been relatively stable for a while, and the CN ratio's been relatively
There's a couple ways, and actually we're going to be teaching you some of them today. In fact, what we're going to be doing is we're going to be doing a bioassay of all different stages of this. And so you can look at your response, but just by looking at it, you can, well, it's an issue of looking, an issue of smelling, an issue of looking at your temperature, and then basically doing bioassays. And what they'll do is they've turned these this is sort of an engine system. You know, this is a biological engine. And what they'll do is you look at specific indicators to tell you when you've reached this stage. Certain gases and things like that tells you that you're here. Okay, certain colors tell you you're here. Certain temperatures tell you you're here versus here. Though potentially you could be here or here in temperature-wise. But so you need to look at all these indicators together to tell you where in this system you are. Okay? Go.
Sorry, humic acid again.
Humic acid again. Okay.
How do you measure that?
How do you measure humic acids? Well, you can do a pH, the sort of simple pH, and you can also, what we're going to be doing is we're going to be doing the bioassay. We're basically looking at plant response to this. But certainly if you have too much acid, your plant response is not necessarily going to be good. You need to have some of it, and that was that concentration. Do you remember there was a concentration on that one table?
This has been a production of Cornell University, on the web at cornell.edu.